Hello students, in this session we'll be discussing about principles of programming using C second laboratory program. So the second laboratory program would be to compute the roots of a quadratic equation by accepting the coefficient along with printing the appropriate messages. So the objective of this program would be to develop the logic to find roots of quadratic equation and also to find the nature of the roots. So we know that the standard form of the quadratic equation is given by ax square plus bx plus c, which is equated to 0. So we can easily compute the roots of a quadratic equation with the given standard formula. So the formula looks like x equals to minus b plus or minus roots of b square minus 4ac by 2a. So now let us understand this program in a better way with the help of algorithm and a flowchart. Before moving our discussion to the algorithm, let us understand the meaning of discriminant. Here, b square minus 4ac in the formula above is called the discriminant because it can discriminate between the possible types of answer. So, here are the two solutions that can be obtained using this b square minus 4ac, which is called as the discriminant. So, when b square minus 4ac is positive, we get two real solutions. The second case would be when it is 0, we get just one real solution. So when it is negative, we get two complex solution, which is also called as imaginary values. So now let us move our discussion to the algorithm. As usual, the first step of the algorithm would be to start the procedure. The second step of algorithm says that to read the values for a, b and c, that is the coefficients of quadratic equation such that a not equal to 0, that is the value of the coefficient should not be equal to the value of 0. The third step, we are computing the discriminant values to find the nature of the roots. So we know that if the discriminant value is 0, then we should go to step 7, else go to step 5. So now let us know what is step 7 is. Computing. So compute x1 equals to x2. So here we are computing two roots with the formula minus b slash 2 star a. So this formula is used when discriminant value is 0. That is, it prints the message the two real and equal roots. That is, the roots would be real and equal and displays x1 and x2 and go to step 10. So the step 10 would be to stop. After printing the messages, it will go to the step 10 and stop its execution. So if the condition becomes false, it will go to step 5. So the step 5 will check for the discriminant value which is greater than 0 or the non-negative number. So if this condition is true, then it will go to step 8. So our step 8 says that compute x1 and x2, that is two different roots with this particular formula. So the formula of x1 would be minus b plus square root of discriminant divided by 2 star a, that is 2 multiplied with a. As like this, we can compute the second root with the formula minus b minus square root of discriminant by 2 star a. As like this, we can compute the two roots. So when discriminant value is greater than 0 or the non-negative number, it says that the result would be real and distinct. That is, the two roots are real and distinct. So if and it will display the roots, that is x1 and x2 root. So if the condition becomes true, it will go to the step 10. So our step 10 would be to stop the execution. What if the condition becomes false? That is, if the discriminant value is not greater than 0, it will go to the step 6. The step 6 would be discriminant value less than 0. So we know that if the discriminant value is less than 0, it is a negative number. If the discriminant value is less than 0, it will go to the step 9 where it will compute the two different roots. So here we'll get the our roots as imaginary. So here it is computing two roots. That is, it is computing the roots of x1 with the formula minus b by 2 star a whereas the real part of the complex roots, and x2, the root x2 is computed by the formula, that is square root of absolute value into discriminant value divided by 2 star a, the imaginary part of the complex roots. So after computing this, it will display the roots, that is x1 and x2 root will be printed, and second root, that is x1 plus x2 will be printed. So this is the first root and this is the second root. So after this step, it will go to the 10th step and it will stop its execution. So this is about the algorithm of our program. So now let us understand the program with the flowchart. So we know that flowchart is an pictorial representation. So we represent each and every step of algorithm using different notations. So we are starting our program with this oval kind of symbol. Then we are reading the inputs with the rectangle kind of notation, then followed by the rectangle shape. So this is used to computation. This is used for computation. So after starting our execution, it will read the coefficients values. So the coefficients values would be A, B, and C. So after reading the coefficient values, it will first calculate the discriminant value, that is, the discriminant value would be calculated by the formula b square minus 4ac. So this b square minus 4ac will determine the nature of the roots. That is, whether it will check whether the discriminant value is equals to 0 or greater than 0 or it is lesser than 0. So we know that if the discriminant value is equals to 0, if the condition is true, it will come to this loop and it will compute the two roots by printing the appropriate messages. So we know that if the discriminant value is equals to 0, the roots would be equal. So the two roots would be equal. So if this condition becomes false, it will go to the next condition or the next step and it will check whether the discriminant value is greater than 0. So if the discriminant value is greater than 0, if the condition is true, it will compute two roots by printing the message such that it is the roots are real and distinct, and it will print the values of x1 and x2. So what happens if the condition is either discriminant equal to 0 or discriminant is greater than 0? So if both the conditions are false, obviously the discriminant value will be less than 0, that is the negative value. So if the discriminant value is less than 0, it will compute the roots using this formula and it will print the results as roots are imaginary. So after running this loop, it will just exit from the loop and it will go to the stop stage. So this is about flowchart of our program. So now let us understand the actual programming code. So as usual, we are starting our program with the two header file. That is, the first one would be hash include stdio.h and hash include math.h. So here we know that we are including stdio.h because of printf and scanf statement, which are also called as input output statements. And also we are making use of one more header file called as the math.h. We are making use of this math just because we are using the math function. So if we are using our math function anywhere in the program, we should include the math.h header file. Then we are starting our program with the void main. By opening the curly braces, we are performing the variable declaration using the float data type. So after that, we are taking the two input and output statements, that is printf, and one is printf and one is scanf. So the first printf statement would be to enter the coefficients values of a, b, and c. So in the scanf, the type specifier or the format specifier would be percentage %f, since we are using the floating point data type. So here we are reading the values of all the three coefficients. So as we know that discriminant plays a vital role in our program, we are first calculating the discriminant value. So based on this discriminant value, we are equating to 0 and assigning that to 0 using arithmetical operations, and we are just checking the nature of the roots. So if the discriminant value So we can compute the discriminant value with the formula b square minus 4ac. So whatever the formula here given will compute the value of a discriminant, and it will be evaluated or it will be checked against 0. So if the discriminant value is 0, then the roots are computed using this formula. So the print statement will print that the roots are real and equal. So after this printing this print statement, it will also print the roots of this both the expression, that is x1 and x2 roots will be printed in the using the format specifier percentage f. So here we are making use of percentage f format specifier such that the result would be printed in floating point fashion. So here x1 is used to store the results of the first root, and whereas x2 is used to store the results of second root. So if the condition becomes false, it will go to the else if statement, and it will just check if the discriminant value is greater than 0. So if this condition becomes true, it will compute two roots x1 and x2 by this formula, and it will just print the message the roots are real and distinct. So after printing this message, it will go to the next print statement, and it will print the roots of x1 and x2. So here also the result would be in the floating point fashion, and the roots are stored in the variable x1 and x2. So if the both the condition becomes false, then it is understood that the discriminant value is obviously less than 0. So we know that if the discriminant value is less than 0, then obviously the result would be imaginary. So it will compute the imaginary roots using this formula, and it will print the roots are imaginary, and the results of roots would be stored here in this variable. So here we are making use of this f abs. So f abs stands for floating point absolute. So now let us check the output of our program. So the first output of the program would be enter the coefficients a, b and c. So here we are giving the values 1, 2 and 3. So when this coefficients values are evaluated to the discriminant value, it will give the imaginary results, because when this values are computed with the discriminant value formula, that is b square minus 4ac, it will give the negative answers, and hence we know that the roots would be imaginary, and these are the roots value of this value. So now let us check for the second output. So the second output coefficients values would be 4, 4 and 1. So here the roots are real and equal. So what is the meaning of roots are real and equal? So we get the roots are real and equals when the discriminant value is equals to 0. So when 441 is computed against b square minus 4ac, it will give the results as 0. So we know that discriminant value is also 0, and here we are computing this discriminant value against the value 0. So when both the numbers are 0, so the print statement would print the roots are real and equal along with printing its results. So now let us check the last output. So the last coefficient values of a, b and c would be 3, 6 and 2. So when we enter 362 and when we compute these values with the help of discriminant standard formula, that is b square minus 4ac, the b value would be 6, a value would be 3 and c value would be 2. So when these values are evaluated against b square minus 4ac, the output would be real and distinct. So what does real and distinct means is that the discriminant value is greater than 0, and hence it will compute the roots by using this formula. It prints this message and displays the roots of x1 and x2. So this is the explanation of roots of a quadratic equation.